Hello, today I'm going to show you how to simulate basically any electronics, at least for beginners. So, the software that you can use for that is called KiCad, spelled like this at the top here, KiCad 6. You can get it off their website, or if you're on Linux, off any package manager of your choice. It should be there. When you open the software, this is the window that you will see. On the left over here, you can create a new blank project, and it'll look like this. I just create blank project, I type in the name of it, like test, and yeah, this is what I get. I get a PCB and I get a schematic. We're not going to concern ourselves with the PCB. We're going to concern ourselves with the schematic for today. So I can open that right up in our schematic editor, and it'll look like this. So the reason I'm using KiCad specifically, and not just an electronic simulator, is that if you want to make PCBs or you want to make schematics, and you can do that, and you can run the simulation all in one fell swoop. So I can turn a perfectly valid schematic into a perfectly valid simulation right from here in the software. So let's build a simple circuit. I'm going to use the A button to first of all add a DC source. So under the PSpice area, there should be a V source here that you can place. I'm pretty sure that you can map any symbol to be a DC source, but I haven't done that yet, so I'm just going to use this one and change the value of it by double-clicking on the second label over here. Double-click and then type in the amount of volts you want. So I want 5 volts coming out of this DC supply. So that's already set up, and the simulator knows what to do with that. Next, I'm gonna build the rest of the circuit out. So let's say I want a specific diode, the specific signal diode. I've got these in a box on my bench next to me. Next, I'll add in a passive resistor over here and link it all together with wires. It's already a circuit. There. Perfect. So we have a perfectly functional, valid schematic circuit over here. And I want to simulate that, not just use it as a drawing and turn it into a PCB. I want to see what the voltages look like on a simulation. So I'm going to go under the Inspect tab in the KiCad 6. The simulator here is under the Inspect tab, and click that. And this is what it looks like. You got all these empty windows and a couple of options at the top. I can't run or stop the simulation yet. Well, why is that? First of all these components are missing labels. They have a question mark next to their names. So let's fix it. The simulator needs that. Gonna open up this little menu up here and hit annotate. It'll automatically name all the components. There, we got V1, D1, R1, perfect. The resistor needs a value. I'm gonna double click on the R underneath the top one. This is the value, and type in 10K. We got a 10K resistor. That the simulator should take that and work with that just fine. The diode should also just work, right? Perfect. Still can't hit start. There's one more thing we're missing. Well, there's more things, but we still need a 0 reference voltage from underneath the PSpice area in the KiCad library. We've got this 0 over here. Gonna select that. Looks like this, and link it up to the negative terminal of the DC voltage supply. And we still can't run the simulation. Well, why is that? It's because we're not feeding any commands into the simulator yet. The simulator doesn't know what to do with all of this, so we're going to tell it specifically what to do. So hit T, or the add text function over here, and type in .tran space 1 space 2. So what this is a command that we're giving to the simulator. The simulator that runs in the background of KiCad, well, it runs off of files that describe the electronics and what you want to be doing. So, you know, all this resistor, this diode, this DC voltage supply in the background is being represented as a couple lines of formatting language, right, for the simulator. And that's what this is. This is a directive that tells it to do a transient analysis at a 1 second time step for 2 seconds. So I'm pretty sure the first parameter doesn't matter all that much because the time steps in the simulation are automatically generated based on how high of a frequency your circuit is experiencing. And the second parameter over here is how many seconds how many seconds of simulation you want to run. So we'll see what that looks like in a moment. So yeah, just type that in text and put that anywhere on the schematic, doesn't matter. Now we can finally run or stop our simulation. It still doesn't work. And the reason that is because under our simulator, ngSpice, as it's called, all the passive components are by default. If you click on Spice model on the resistor, for instance, you've got these passive types that should just work as a perfect resistor example under the simulation. But more interesting active component, such as this diode over here, when I go under the Spice model, well, it's not a passive component, and it's missing a library under the model tab over here. So what a library is it describes what this component is supposed to do in the simulation. And these libraries are typically what look like text files or lib files. Well, they are text files, and they're downloaded from the manufacturers or people that create them. And you can typically find them on GitHub for specific models of whatever components you have. So I'm going to do exactly that. I'm going to open up a browser over here and head straight and look straight for that model directly. So we want 1N4148 diode Spice model. There we go, and I'll type in Git at the end because I'm pretty sure it's on GitHub, like most of the Spice models that I can find. So right here we got what looks, yeah, this looks exactly like the model that we want. So I already have this downloaded on my system. You can download it or literally copy paste it into a .lib file. It's generally convenient to store these next to near your project directory, because when I go select file, I'm 3 test directories in, but yeah, I go into electronics, Spice model, I have it right here, 1N4148.lib, open. Here's all the text that we just saw on GitHub, straight in this window that describes what the diode is, how it works. So with these models that you download off the internet, there's 1 or 2 important things to note. Look out for this line. This is a directive that means it's a subcomponent or subcircuit. You've got a few different types of active components. Subcircuits are the most common ones. And this diode is described as a subcircuit in this instance. You might have diodes, BJTs, MOSFETs, etc. But this directive lets us know that it's a subcircuit, and you have to select that. You've also got this model directive that describes these other components here. So this is reserved for subcircuits, whereas this .model is reserved for things like BJT, diode, MOSFETs, and all that. And you can see over here, we got a D. That means it's a diode. Q would mean a bijunction transistor, and not sure about the other ones, but we're dealing with a subcircuit for now because this thing is modeled as a subcircuit. As you can see, it has some extra components written in there. This is what the modeling language looks like for the simulator that we're using. This is what's going on in the background of all this GUI that we've got going on. But we want a schematic at the same time, so we're not going to deal with that so much. So we know we have this diode. We know it's a subcircuit. It's okay. Excellent. Looks like it's set up. Now let's run the simulation. Looks like it worked. Let's get a voltage probe in there. Click on the probe and you can select any wire to probe the voltage. So here, straight from our DC source, it's 5 volts. Look, we got a chart and everything. What about over here? It's 0 volts. Now, why is that? It's because of a very simple reason. I'm gonna show the pin numbers on this diode over here. This is a crucial step that confused me for a while trying to get into circuit simulation. So I'm going to show the pin numbers here on this diode, and the input is pin 2 and the output is pin 1. But when we look at the Spice model under this line that I mentioned earlier, under subcircuit, you can see that it orders its pins probably in another order. Usually, usually under the subcircuit, like if you're dealing with an op amp or an IC, it'll actually list the names of the pins and you can match it up properly. But here I'm gonna have to assume that what we got here on the schematic is laid out backwards to what we got here on the subcircuit line. So I'm gonna type in an alternate node sequence and just put it in the other way around. These numbers I'm typing in here represent the pins on the image that we're using. Like this diode image that we're using, this schematic, I could replace that with essentially anything and just assign the subcircuit model to it. But yeah, we just have to make sure the pins line up properly to what's in this directive. So I'm pretty sure that's right. I think we just have to swap them around. So we're here in this case, we're mapping this pin to pin 1 on the simulation. The way that these are laid out on this line is how the indexing is going to work. So this is index 1, this is index 2, and consequently down here under the alternate node sequence, this is also index 1, index 2, and it maps them. It maps the two, in case that wasn't clear enough yet. So yeah, it would look like this by default, but we're making it look like this with a single space between all the numbers. And we're going to hit OK. OK. Now let's rerun the simulation. And you can see now that we are getting a voltage in this section of the circuit just past before and after the diode. Remember, the red one was before, the blue one was after. We can delete them by double clicking on them, delete the probes, and place them again. So here we got the 5-volt direct DC output, and we got the voltage directly after the diode. We got a little bit of a voltage drop across the diode. We can't put a probe here because it's just 0, it's ground, it's always going to be 0. We can also probe the current by clicking on this section of the component, and see on the right over here, which I'll delete these for clarity, we got the green chart showing us what the current is at this resistor, as you can see. So IR1, it's listed here pretty clear, and the amps are over here on the right. So that's how you get set up and get started simulating circuits. The principles that we apply to this diode also happen to apply to basically any subcircuit. You want to get an op amp in there, you want to get an IC in there, you just look up a symbol for it, put it in, and then map the pins correctly to whatever model you can find on the internet. And yeah, also you can zoom in on this chart by clicking and dragging a square to zoom in on an exact part, and that'll show you the chart very accurately. And I think that is just about all to say for getting started and set up with simulating whatever circuit. This is good because first of all, you're not typing in the commands one by one in a console. As much as I love using consoles, this is very convenient because you also get a completely valid usable schematic out of it at the same time, and you also get a usable PCB out of it at the same time, as well as running these simulations and probing it. So there's lots of other functions that make this a little better, like labeling things and whatnot, but I'm not going to go into that because that's KiCad specific. Thanks for watching. I hope this was helpful. See ya.